myself. My name is Jonathan Rubin, and I am the chair of the math department at the University of Pittsburgh. And along with Satish Iyengar from statistics at Pitt, I'm one of the organizers of this Science Revealed series. And the idea of Science Revealed is that we have a series of events in which we select topics that we think are of pretty significant public interest at the moment. And we recruit experts, usually from the University of Pittsburgh, sometimes from the community. In this case, everyone here is from Pitt, to present to a public audience what research actually shows about this topic, as opposed to sort of opinions or whatever that can cloud the facts in various media forums. The goal here is to get real expert opinions on or views on these issues, what science can tell us, science and other forms of research can tell us about them, and also what the limitations are. What are the areas where we don't really have firm answers? Okay, so thank the Dietrich School at the University of Pittsburgh for supporting this series. And with that, I'm going to turn things over to Paul Monroe, our moderator for tonight.
Thank you, John. My name is Paul Monroe. I'm on the faculty in the School of Computing Information, and I'm happy to serve as the moderator this evening. Tonight's event is entitled ChatGPT Wrote This Title, Exploring the Impact of AI on Our Minds and Society. Each speaker will have about 10 minutes, and then we'll start entertaining questions after all four speakers have spoken. I want to remind the audience to put any questions into the Q&A, which you should see at the bottom of your Zoom screen, and then we'll address the questions at the end, like I said. So with that, I'll introduce our first speaker, Diane Littman from the Department of Computer Science and LRDC. Go ahead, Diane.
Okay, let me share my screen. Okay, thank you very much, Paul. So as Paul mentioned, I'm Diane Littman, a professor in the School of Computing and Information, and I've also been the director of Pitt's Intelligent Systems Program, which is a graduate program in applied artificial intelligence. And I'd like to begin this panel by providing a brief history of artificial intelligence. As John said, it's been in the news a lot and there's been recent public interest, but the field has actually been around for quite a long time. So I'd just like to give you a sense of the broader view of the field, where it started, and it encompasses a lot more than just ChatGPT and machine learning, which is kind of what you mostly read about these days. So I wanted to start by giving some different viewpoints of what it even means when we talk about artificial intelligence. This term is something that there is no real uniform consensus about how to conceptualize machine intelligence. And in the textbook that I use and many people in the field use, the authors try to take different viewpoints that we've seen over the year of characterizing machine intelligence along two basic dimensions. So comparing the top rows to the bottom rows, one dimension is, are we evaluating intelligence internally or externally? So from an internal perspective, are we looking at how the computer is generating behavior? And you can think of that analogously to thinking, or do we not really care how they're generating the behavior, and it's the behavior itself that we observe when we're interacting with them? An orthogonal way of looking at how to define or characterize machine intelligence is that what is the gold standard for intelligence that we're comparing our computer programs to? So on the left, you can see that various approaches have used humans as the gold standard. And on the right, you can see that other types of research has been addressing a different view of intelligence, that we don't care so much what humans do, but we'd like our machines to act rationally in the sense that they have goals and they're trying to maximize some performance and are acting to achieve behavior that does that. And I think it's useful to keep these four different viewpoints in mind as through the remainder of the panel as you hear different people talk about the topics that they'll be addressing. So with that, I'd just like to give a brief history, and obviously in 10 minutes, I can only do a few very selected milestones, but I wanted to give you a sense of sort of how AI has evolved since even before the term was coined in 1950, all the way to the current day. So in 1950, Alan Turing, and many of you probably heard of him, he was famous for breaking the code, and there was a Broadway play written about this. He was already thinking about how computers could be considered intelligence, and he proposed something called the Turing test, which was a way of evaluating intelligence based on this viewpoint of intelligence as acting humanly. And people still talk about that today, and there's still competitions that sort of follow this paradigm. But the idea is a human interacts with both a computer and another human and doesn't know which is which, and if the computer could fool the human into thinking that they were the human partner, then they would be passing the Turing test. The term artificial intelligence actually was coined in 1956, and even though lots of people don't like the term, it's stuck with us and we're still using it today. And it was coined at a meeting that was convened at Dartmouth University over the summer by different researchers, both from academics and from industry, who were working in, with computers and doing things that were related to intelligence. And they wanted to sort of set the stage and really set the framework for what it might mean for a computer to exhibit intelligence. And an example program from this time was a program developed by Samuel that played checkers. And you'll see that game playing has often been kind of some of the canonical programs to demonstrate intelligence, because many people believe to beat a human in a game, you actually have to be intelligent. So this program, as I said, was developed in the 1950s, but despite its age, it was one of the first to sort of introduce ideas related to machine learning, the idea that a computer can learn over time from experience and improve its behavior. And many of the sort of key ideas that were introduced back then evolved into some of the fundamental paradigms that are still underlying some of the current research even today. Turning to the next decade, the 1960s, there was kind of a ChatGPT moment back then with a program called ELIZA, which, like ChatGPT, was coming out of the field of natural language, the idea that you could communicate with a computer by conversing with it and chatting. ELIZA was much more restricted than ChatGPT. It was only able to sort of simulate a Rogerian psychotherapist, while you can talk to ChatGPT about anything. And it also used very, very different technology. It was really very simple rules that the creator of this, Weizenbaum, wrote a bunch of patterns, and patterns would match what the human said and then kind of rework the sentence to say something that could continue the conversation. But like ChatGPT, it created quite a splash, and people, even when told it was a computer and that it was not doing anything at all intelligent, attributed all sorts of human-like and intelligent underpinnings to this program, just because it was very compelling, especially, back in the 1960s. In the 1970s, AI kind of went commercial, and there was a field of systems that were called expert systems that, as I said, had a lot of commercial impact. These systems were trying to simulate the expertise in a very specific domain. So, for example, medicine. Before coming to Pitt, I worked at AT&T Bell Labs, and it had its expert system for diagnosing telephone switching systems. And the idea here was, Back then, there wasn't the amount of data that we have, and the machines were also not nearly as powerful. So the idea was you could build a system by interviewing an expert, writing down rules to capture their expertise in a way that a computer could process to generate interesting, intelligent behaviors in this very specific domain. And if you haven't kind of inferred this, hopefully one thing you'll notice is that in these early systems, whether or not you think their intelligence, their scope of their behavior was very limited. It was like, checkers could play checkers and nothing else. Eliza could be a therapist and nothing else. These expert systems had expertise in one area, but not in another. And I put this particular slide here just to show that one of the founders of this field, Bruce Buchanan, was actually recruited from Stanford to join Pitt and was one of the people who really built up the AI faculty and expertise in the current computer science department. 1990s started turning into the realm of IBM having big splash events. So in 1990s, they developed a computer program called Deep Blue, which played chess. And so this contributed to the areas, again, of game playing like checkers, but it built on a field of AI involved in search with the idea of chess with any board game and the fact that the rules are very well defined, you can exhaustively search what the player whose turn it is could do, what the next player can do, what the player could do in response to all those things, much more something that humans couldn't do. Look that far ahead, sort of all the way the possible ways the game can end. And they created this big competition where they had their system Deep Blue pay the human grandmaster at the time, and Deep Blue won that competition. And so that was kind of the first case where people started, really seeing the power of AI as far as excelling at above human levels. In 2011, IBM did it again in a very different kind of game scenario. Instead of chess, which was very well defined, they moved to the game Jeopardy. This built on techniques coming out of the field of natural language processing. They built this system, and just like with Deep Blue, they created a competition competing with Watson competing against the best human players at the time. It was televised. Here, if you're a Jeopardy fan, you probably recognized Ken Jennings, who was one of the best players at the time. And as you can see from the score here, Watson beat the players during this competition. So again, the same kind of outcome. And then kind of one of the most recent competitions in this paradigm was in 2015, now switching from IBM to Google. They developed a system called AlphaGo, which played the game of Go, which was believed to be much, much more difficult than chess. They developed a system. They had a competition with an expert human, one of the best experts players in the world. And again, the computer program was able to beat the human at this much more difficult game. And so that brings us to today, where probably most of you have, or I'm guessing many of you have interacted with ChatGPT from OpenAI. This comes out of technology from the field of natural language processing. In some ways, as I said, it's quite like Eliza, but the technology that it's using is based on something called large language models, which is totally different than the technology underlying Eliza, and really takes advantage of modern machine learning methods, as well as all the data that it's able to train on. And I'm not going to go into details because I believe many of the other speakers will talk more about ChatGPT. So with that, I'll turn it back to Paul.
Thank you. It took me a minute to unmute. Thank you, Diane. Our next speaker is Colin Allen. Colin is the Director of Graduate Studies for the Department of History and Philosophy of Science. Go ahead, Alan. Colin.
Thanks. Let me just get the screen shared here and hit the play button, and hopefully this will work. All right. So thanks to Diane for that quick history of AI and bringing us up to date with the current state of affairs, where many of you will have heard of ChatGPT and perhaps some of the other systems that are making news at the moment. What I'll add to the history is that the rapid progress that we've seen over the last months and even weeks is the result of pursuing an approach to AI that also goes all the way back to the 1950s, but takes the brain as an inspiration for the architecture of these systems and tries to build what are called artificial neural networks that can in some way learn in ways that are thought to be similar to the way in which biological brains learn. But there's a lot of dispute about just how similar those methods are. Nevertheless, we take these ideas that go back to the 1950s, in fact, and that have been worked on progressively through the subsequent decades, with some particular progress in a particular learning approach called backward error propagation in the 1980s, that then was very limited. I ran some backward error propagation learning systems with very small networks in the 1980s. It was 3 weeks of compute time for the very simple networks. Now we've got networks which are many orders of magnitude bigger, and many of the successes that we're seeing are due to the size of the network and the amount of training data that's available for those networks. So since the 1980s, we now have the internet and the World Wide Web as we know them, and this has enabled corporations like Google and Microsoft, working with OpenAI and so forth, to gather huge amounts of text data in order to train these networks in a way that I'm going to not explain in full detail. The result is systems that are very, very compelling when it comes to our interactions with them. And so if you've played with ChatGPT or with Google's Bard or with Microsoft's Bing Chat, which is also based on GPT, then you'll be impressed, I think, by the kind of natural fluency of language that comes out of those systems and the kinds of novel things that they seem to be able to do. So, for instance, you can ask ChatGPT to write you a defense of the Second Amendment in the form of a limerick, right? And it will do this, and it will do a passable job at it. And it's just surprising that anything that's a machine can do this. And this also then relates to what Diane talked about with respect to the Turing test. More and more people are reaching the point where they feel as though they can be fooled by these systems, at least, or maybe even attribute to them a kind of level of intelligence that appears to be human. And most famously, Google, with its these are called large language models, had an engineer last summer who came to the conclusion that Google's large language model was sentient, and therefore there were ethical issues involved in interacting with it, and Google fired him. So there was this sort of outright statement of the sentience or consciousness of this system that was driven by the kinds of linguistic interactions it's possible to have with these systems. Meanwhile, these systems are being rolled out in various ways for various applications that seem to threaten all sorts of things, from higher education to jobs writing basic ad copy or legal briefs and things like this. And there's an enormous amount of concern about what the ethics of doing this are, and where this is all heading. Are we actually creating a kind of intelligence that's better than us? So again, to refer to Diane Lippman's talk, the chess players, the best chess computers and the best Go computers cannot be beaten by humans. So what if they get better than us at the things that we really take pride in historically, which is our linguistic abilities and our ability to reason in language? So who's afraid of the big bang language model? There's a lot of concern about this. And it's also exemplified then by people who start off with a critical attitude. So this is a software engineer who posted a blog on Medium saying, I asked ChatGPT about the meaning of life to break it. It broke me because he was so impressed by the response that it gave that I'm not going to read to you, that he thought that this was just not possible coming out of a machine. And those of you who know The Hitchhiker's Guide to the Galaxy will get this reference, but if you don't, I'm not going to explain it to you. Nevertheless, the level of fluency that this machine produces and the kinds of prompts to which it can give seemingly intelligent responses has led many people to think that we're on the brink of a real transition from old AI systems that were very narrow and focused, as Diane pointed out, on specific kinds of tasks or capabilities or even games, to something that's much, much, much more general. And this has raised all kinds of concerns. Now, there's huge commercial forces at work here. And some of you may have seen the 60 Minutes program on Sunday, just a few days ago, in which Scott Pelley interviewed Sundar Pichai, who's the CEO of Google, about their large language model called Bard, which is also creating something of a splash. Now, there are a number of things to say about this. I'm not going to be able to play the video during this presentation here. But you can see from the way in which 60 Minutes itself promoted this video that they're claiming really remarkable capacities for this system. So one AI program spoke in a foreign language it was never trained to know. This mysterious behavior called emergent properties has been happening, where AI unexpectedly teaches itself a new skill. Now, I've been teaching philosophy of science to undergraduates this semester, and we've spent a week or two on emergent properties. And the whole idea that this is mysterious is really part of a kind of for want of a better term, I will call mystery mongering among the people producing these systems. It serves their commercial interest to pretend that these things are acting in ways that are inexplicable to us, and that spoken a foreign language it was never trained to know. This is a half-truth at best. That is, its training data, which is huge, undoubtedly contained lots and lots of examples of the particular language that they featured in this video clip, which was Bengali. So even though they hadn't set out to teach it Bengali, they threw a learning mechanism that was capable of doing the same things with Bengali that it does with English. So we shouldn't really be surprised at all that if you give it a question in Bengali, it will respond just as appropriately in Bengali as it does in English. Furthermore, Pelley quizzed Pichai, because Pichai said, well, we really don't understand how this works, which is part of the mystery mongering. And he said, Pelley said, so you're telling us you're releasing in the public something that you don't know how it works. How can you justify that? And Pichai just kind of smiles and goes, well, we don't really understand how humans work either. And I want to say, actually, we do know a fair amount about how these work, even though you will hear lots and lots of discussion among academics about the opaqueness or lack of transparency in these systems. They're complicated, but as a matter of fact, they're nowhere near as complicated as human beings. And we can probe them in ways that we cannot probe human beings. And so the prospects for understanding them are much greater than the PR campaign of corporations such as Google and such as Microsoft would suggest. And in both cases, these corporations, in particular, I think Google really feels that it has fallen behind with respect to the search business, given the way in which Microsoft embraced the GPT system and ChatGPT and built it into their Bing chat. And so it behooves them to say, we've got something better. Look how marvelous it is. And we should all just be really, really skeptical of this. And that brings me to my own project, which has been going on here at PIP for a couple of years, which is with funding from the Templeton World Charity Foundation. We've been thinking about how to be wise about these developments in AI. So practical wisdom and intelligent machines, machine wisdom for short. This gives us an ambiguity that we like. It's like, is it the wisdom of the machines or is it the human wisdom about the machines? We've been primarily focused on the latter, but we think the things that we say about the latter are relevant to the former. And in particular, what these machines lack, and what many people in this space also seem to lack, is kind of understanding of the limits of what it is that they know. So let's grant that the machine can do a lot of things. Let's grant that Google and OpenAI and the Microsoft engineers can do a lot of things, but they tend to be rather blasé about what the limits of that knowledge is. They tend to think that these things have more capability than they have, and the machine itself has, in fact, no way of assessing its own failures spontaneously. It can be prompted into recognizing mistake, but it just has no means for recognizing its own mistakes. And this is dangerous in a way in which the Uber car that ran over the woman in Arizona exposes the danger. That there was a person in the car who was supposed to be monitoring its self-driving capabilities. She'd been sitting there for hours and had been behaving basically well. So she was on her phone paying no attention, and it ran over somebody who pushed a bicycle across the road in front of the car. And this illustrates that we are not training people who work with these things, but also we're not thinking hard enough, even at the very early developmental stages of this, about where they can go wrong. So I have been giving a talk in which I asked this question: how much are large language models narrowing the gap to human intelligence? I haven't defined for you what human intelligence is, but there are implicit comparisons all over the place here. What are the large language models? I've given you some names. We haven't gone into the details of how they actually work. And can we quantify how much they are narrowing this gap? And there are numerous attempts to do this, but many of those attempts either obfuscate what it is the machines are actually doing, or they rely on tests that the machine has, in some sense, been directly trained on in ways that humans themselves are not trained on when taking those steps. So are we on the way to AGI? Melanie Mitchell, who's an AI worker, says, actually, the current state is like a monkey climbing a tree, thinking it's on the way to the moon. I've been in a little bit of a debate with some philosophers who want to argue that she's too pessimistic. I think that there are ways when you take a critical attitude to these systems and rather than just being accepting of what they say as being very impressive, which it is, but actually try to expose their shortcomings, we can go a long way towards thinking that actually there's still quite a long way to go, which is not to say that these systems are not going to be extraordinarily useful for all sorts of purposes. So I think my time is more or less up. So I'll pause there and hope to address some questions later on.
Thank you, Colin. Our next speaker is Annette V. Annette is the director of the composition program in the Department of English. Go ahead.
Hi, everyone. I am finding the correct thing to share. It's not sharing the correct thing. Hold on just a second here. You would think after all this time. Okay, there we go. Hopefully everybody can see it. Let me know if that's not the case. I'm really excited that Colin Allen set me up here to think about the whether large language models are approaching artificial general intelligence, because that is kind of a backdrop to what I'm talking about today, which is specifically about the writing aspect of this. And that's partly coming from the fact that I hold a director position here in the composition program, which basically runs the kind of gen ed writing classes at Pitt. So that's my perspective here. So we are. This is a kind of setup. This is what we've been talking about, right? And so, like the ability of these artificial intelligence writing systems, the large language models such as ChatGPT, have gotten really good recently, such that we're all talking about it. That's the reason why you're all here. And here, this is a Dilbert cartoon that just says, "Wally, your status report appears to have been written by a commercial grade AI." He says, thank you, I appreciate the compliment. Sort of suggesting that they are rivaling actual human writing, which is a little disconcerting to a lot of people who are teachers. And I saw there's a question in the Q&A too that hopefully we'll have a chance to address. My research is taking things from a kind of historical angle, though, and I want to note that people have been automating writing for a long time in very different ways. But it's been going on for a long time. So I'm going to run through very quickly 4 of many approaches to automating writing through historical periods. So that's beginning in the 18th century, a mechanical approach, in the 19th century, a spiritual approach to automating writing, in the 20th century, a computational logical approach, which actually Diane already covered quite a bit of, which is wonderful. And then in the 21st century, the simulational deep learning approach, which Colin was focusing on. So to begin, the mechanical approaches to automating writing. And this is, I have to say, maybe my favorite era. So this is 18th century Europe. And there was at the time a kind of movement to do automata. So these were interesting little mechanisms that would recreate some aspect of life. They were often done by engineers or Swiss watchmakers as a kind of demonstration of the beautiful, intricate engineering that were possible. So this particular machine, Vaucanson's automata, was a defecating duck. And it literally could consume things, and then it looked like it was defecating at the end. People found it very exciting. It was shown in a big hall in Paris in the 18th century. It was actually a little bit of a parlor trick, but there were other things like this that were circulating. And you can see here in this picture, there was a drum player and a flute player that could actually play. So most interesting to me are the writing machines that were also automata. So this is, for the interest of time, I'm not going to play these videos, but there are these beautiful videos showing these things that are still working. So this one was from 1760, Friedrich von Knaus's writing machine, which actually you can see, kind of it writes something, and it's got a big mechanism in the back that drives it. Oh, it's going to play. I don't want that. This is Henri Maillardet's draftsman writer, so circa 1800. This is actually held at the Franklin Institute in Philadelphia. And again, this was a kind of mechanism that was showing off a very fine kind of engineering that could physically write. So this is a kind of breakdown of what it looked like. So you can see there's it looks like a fine watch. It's got all these cams. There's fine brass engineering. They had to restore it in the last a couple decades at the Franklin Institute. And it's a beautiful story. If you've seen the movie Hugo, it's based on this particular automaton. So they're very impressive mechanical feats. And so you can see here's the result of one of these kinds of writers. It was actually drawing cursive, and it could do it with its hands. But were these artificial intelligence? So Colin asked that question about language models and are they approaching artificial intelligence? Now, these don't appear to be artificial intelligence to us. They're just mechanical. But we need to think back to the ideas of science happening in the 18th century. And in particular, we can use Gottfried Leibniz as an example, this kind of idea that calculation is the crux of reasoning. And in particular, and here is a shout out to Pitt. This is my favorite little machine that Pitt has. And this is was a recreation by somebody in our History and Philosophy of Science department who's now emeritus. And showing this was a Leibniz machine that was never designed in his lifetime, but showed Leibniz's interest in the intersection between math and language and the mathematics of cryptography. So these things were quite connected, and this could be thought of as a kind of very early computing. And so when we think about Leibniz and this idea of calculation being at the center of reasoning, and that we can kind of put across this idea of mechanistic philosophy that was dominant during this period, the idea of the clockwork universe. And that is that nature's, humans, the whole world was like a mechanism that lacked agency and were passive. And so we were wound from the outside, presumably by God. And so one of the questions to why automate writing in this particular time period would be to be as a kind of God, that the watchmakers could be a sort of God creating life, which was a kind of artificial intelligence because of that idea of mechanism happening at the time. So moving on to spiritualist approaches to automating writing. So this, I'm looking at 19th century US and Europe. And here is an example of, for instance, spirit photography. So we have to think the 19th century was a period of a great deal of disease, mothers dying in childbirth, there was a lot of war. And so there was a kind of desire to like kind of recreate and bring back the lost people. You know, there's a lot of mourning and a lot of death. And so some of these things are kind of in the background in this kind of Victorian Gothic era. But these are some pretty cool examples of ways that people did that. And thinking too also about technologies of reenchantment. So in the era of kind of automation, this is after the Industrial Revolution or in the thick of it. And these kinds of technologies then would do things that felt kind of like magic. So the telegraph could change messages, send messages across long distances. The telephone could kind of ventriloquize voices across long distances. The camera could recreate the image of somebody's face and keep it in time. When you step back and think about these things, they are quite magical, and they felt that magical at the time. Also, the Ouija board invented in 1890. Again, these are channeling spirits. And in here, you can see the Ouija board is actually using it to write. And these were quite popular. So here's on the cover of the Saturday Evening Post, this Norman Rockwell painting indicating, you know, that it was kind of a fun thing for couples to do on a date. And from the literary side, William Butler Yeats and his wife George are shown here. She introduced him to automatic writing. So this was a kind of literary approach to channeling the spirits and then kind of letting the unconscious, the spirits, just let the writing happen. And so in that period, or in that scheme, it would be like the spirits were treating the body as a kind of mechanism. So there's some parallels to that kind of 18th century idea where God would be winding the mechanism. In this idea, the spirits would be sort of working through us as mechanisms in order to produce writing. So these ideas were like a recreation of humans and human functions, such as writing, through spiritual rather than mechanical means. And what's interesting is you may have seen these kinds of stories happening, that there's a kind of reinvigoration of this idea. When people lose loved ones, we have right now so much data exhaust, all of this text that we send to each other, emails, et cetera. And there's a kind of movement from some companies and other places that you can send that data and recreate somebody so that you can have a kind of a chat bot of somebody after they have passed. And some theorists are calling these Thanabots. It's very interesting. I'd be happy to talk about that in Q&A. So this question about why automate writing through spirituals, maybe the answer may be kind of a reenchantment, a kind of bringing back a magic in the world in an era of automation. So third movement, early computational approaches to automating writing. And this is mid-20th century, and this is the era that Diane covered so beautifully too. Again, I always love to start with this article, Computing Machinery Intelligence from 1950 that Diane mentioned by Alan Turing. And in this article, this was the introduction of the Turing test, but he used the idea of language to consider this question of whether machines could think. And this question of machines could think was a kind of early AI question, but he's looking at language, in particular testing gender in language as a kind of way of thinking through this question. So language was really fundamental to these early ideas of AI. And at the time, the idea was there was a kind of idea that you could solve the problem of language generation with computers. And this idea, there was a little bit of a hubris to that. This was kind of a top-down approach. But again, language was a test case for early AI, or recreating the brain of humans. And I have to note Alan Newell and Herb Simon, John Shaw. So Newell and Simon they were in Pittsburgh. They worked at Carnegie Mellon, and they wrote the first AI program in 1956, same year as the Dartmouth conference. And there was this idea that they could potentially solve the problem of natural language processing and generation through logic. This kind of intuiting, you could imagine a vision of the brain and solve problems of language. As a kind of counter to that, I want to bring up Margaret Masterman, who was the founder of the Cambridge Language Research Unit, which was a pioneering site in artificial intelligence. She and her group approached language generation semantically and statistically, which is a little closer to how it's done now. She was also, not coincidentally, a student of Wittgenstein, whose later theories kind of approach language in that way. And I want to also note that Turing was also very strongly influenced by Wittgenstein, and that the questions that he's asking in that piece about computing machinery and intelligence are largely inspired by Wittgenstein. And in this era, this mid-20th century era, there was a kind of anxiety for authors then too. So there's a great short story by Roald Dahl called The Great Automatic Grammatizator. And that is, he imagines this kind of engineer who could write genre fiction better than romance writers or lots of other kind of authors, and kind of automates them out of the business. So finally, machine learning and statistical approaches. So this is basically where we are now with all of the GPTs, such as ChatGPT. And so you may or may not have been paying attention to this in 2019, but the release of GPT-2 was a kind of watershed moment where the generation of language became, it felt on the outside kind of more suddenly quite coherent, that it could generate sentences and suggest a kind of early reasoning that was pretty impressive to a number of people working in AI at the time. So moving next to GPT-3 in 2020, this is a little bit about the details of what it's trained on. So this is 45 terabytes of textual data, which is a huge amount of data. And you can see here what it's built on. So most of it is Common Crawl, which is 8 years of web crawling. It's raw web page data. It's got some light filtering, not a lot of filtering, but this is just general text from the web. Web text 2 is a text of web pages from all outbound Reddit links from posts with 3 or more upvotes. Reddit links, I just want to note that. And there's also books, databases, and Wikipedia, which is a rather small set of the database. So looking at this kind of how this data is being made and what the implications are of it is a really important kind of pushback to the kind of relentlessness of these large language models right now. And the most important paper that's come out of this movement was one by Emily Bender, Timnit Gebru, Angelina McMillan-Major, and Margaret Mitchell. And they introduced this idea of the dangers of stochastic parrots. So parrots being a kind of reproduction of language without understanding, or without having stakes in that language, without having an investment in that language. And the stochastic part of it being a little bit random, like it's unpredictable, and it's moving somewhat unpredictably. So all of this is showing this is the data matters for these things. So OpenAI or GPT-2 functions a lot better on some text than others. This really matters because we're thinking about whose writing is being emulated. And the difference between human and AI writing, Chomsky wrote an op-ed about this too, knowing about the science of linguistics. And so this is, again, getting back to this idea that Colin was introducing about the movement from large language models to AGI. So these are the questions that I'm going to finish with, is that are language models getting us closer to AGI? Do language models lead us to intelligence? And what does that mean for writing? What does that mean for our concepts of intelligence and whose intelligence we're emulating? Thank you.
Thank you, Annette. We have our final speaker is Malihe Alakhani. She recently joined the Department of Computer Science and she specialized in NLP. And Malihe has been actively researching deep network approaches. So go ahead, Malihe.
All right. Well, thank you for the introduction. It's we until now talked about more like a 1,000-foot view and the history of AI and how we got here. Now, I want to focus a little bit on what we are going to look at next, but I also want to take a moment to kind of ask you to focus even more. We've been talking more about AI, just the language technologies and just the influence that they've had on our lives, and what should be next. So language technologies are now gateways to knowledge and community, and they influence different ways that we interact with people offline and online. Right. So if you think about it, AI moderators are now in charge of the moderation and mediation of online spaces. So Reddit forums, Twitter, Facebook, Instagram. Perhaps you've all seen these red flags. This post needs to be checked, fact checked, or this post is going to be removed. Social media influences a lot the ways that we receive information and we form beliefs. We interact with chatbots in the context of education and virtual assistants. In elderly care, we have a number of language technologies that are actively deployed. We order pizza using chatbots, interacting with chatbots. To get information about our bank account, we interact with chatbots. And one part that may not be, as visible is the influence of this language technology in what you may call NLP in law and policy. How we process legal documents, who has access to it, how can we help lawyers? How are these decisions and processes influences the judges' decisions, or the kind of public opinion about important matters. And this doesn't stop here, and this, you're all here, with the introduction of ChatGPT and the fact that it was publicly available. On average, 30 million users per day visited the OpenAI website and particularly used the ChatGPT website as of January of 2023. And it's not just about this service and, using it for rewriting emails or, writing essays or for whatever reason you might want to use it. It's also influenced that, as Colin said, the search system, it's no longer the case that we would just search for an information and the ranking and how Google is preparing that page for us or the top links that it suggests, but rather you can ask Bing, what gift, should I buy for my partner's birthday? Or you can ask Bing to, arrange your next trip to Europe. So they're pervasive. People, there's already been, we've already heard discussions about how journalists might decide to use this. We can search more under the kind of term of computational journalism. That has received a lot of attention from people who are interested in studying misinformation and dealing with misinformation. So language technologies' influence on our lives are just getting bigger and bigger. But I want to just spend a couple minutes, maybe a little more, to tell you about the challenges. We all know that it can answer some questions or help us write an essay, or in that case, what Diane showed us a talk on evaluating AI. But there are certain challenges, and this is what the field is going to look at next, the field of natural language processing. One of the kind of bottlenecks is thinking about reasoning, and especially common sense reasoning. So thinking about, there are various definitions, but the fact that the next step after you put toothbrush on, when you're brushing your teeth, the next step after washing your brush would be to, bring it up. And all of this, the steps in between are not actually in the text, are not represented in the text. Or the fact that your mom is older than you, or, even like thinking more situated and in a more multimodal domain, when you say, imagine you're sitting at the dinner table and, someone says, put that vase away. It's covering your face. So what does that away mean? Does it mean like end of universe? Does it mean just 2 inch, to the left? Well, how should I interpret that? We will be thinking about more systems that can coordinate better with us on meaning, and reason and work with us. Systems that can achieve a common ground with us, that can help us understand the concept, that can perhaps influence our beliefs, or accept ours if we need to coordinate to get a task done, even if it's task oriented. We need to think about generalization and robustness. A lot of these systems are still, as powerful as they are, cannot reason on that when you're dealing with the examples in the long tail. So a human kid can go on the street and maybe they've never seen a banana in the middle of the street, but they walk in, they pick it up. Oh, this shouldn't be here. Perhaps it should, maybe let me pick it up and put it somewhere else. So how do we actually reason about the world, and how do we generalize, and how do we make sure that these models are robust enough so we can deploy them for different applications? One of the next kind of frontiers, again, as I already mentioned, is multimodality and embodiment. So we've already seen different companies thinking about including images or different sort of virtual scenarios in language models, but this is going to take time, and this is a huge challenge, really. Designing models that understand the space, that understand action and what's in it, and can coordinate with people who are in that space, is going to be the next challenge for us as a research community. There are a lot of reports on Twitter and, pretty much everywhere where people talk about, ChatGPT hallucinated this citation, or ChatGPT mentioned this fact that is not true. So one of the active research areas is, thinking about how can we use these models, but make sure that they are kind of based on facts. And again, going back to the robustness, they're robust enough so we can, trust them, rely on them for summarizing an article, for example. The next thing that people that you will hear more in the next few years is going to be the size of these models. Again, I think Colin mentioned most systems were task oriented, but now we have this large model that can potentially reason about different tasks, and but I think we are going to in a different way go back and think about ways that we can distill or derive, or kind of a smaller models from these large language models, and supervise them so they are experts, bankers, and so they're expert, they can help nurses, so they're expert, they can help the students, right? So they're the size is manageable, so we can control them. We make sure they're robust. Going back to what Annette talked about the stochastic parrots, right? So we're kind of thinking about the size, but then adding more constraints and robustness, and the fact that they're deployable and so on. And there's already research, again, I know, Emma Struble at CMU, for example, is working on the environmental costs of these models. Are we going to burn the whole planet in this race of training larger and larger language models, and thinking about, what policies we should think about, what are the goals of, this research or this agenda, and how should we treat it? And Finally, trust and persuasion. Another active research area, which is very important, at the kind of sits at the intersection of econ and philosophy and psychology and computer science, thinking about if these models have the power of persuading people to vote for someone or to do something or to buy a product, how should we think about regulating this problem? How should we think about modeling it, and so on? So these are like kind of, overall list of challenges that in the next few years, you will see more and more papers and discussions coming out from companies and kind of universities around these topics. And now I want to give you kind of my perspective, which is a very hopeful perspective. What I tend to think about is, this is an amazing power. This is a very good model. So how can we use this technology to create a more inclusive society? How can we use this technology to provide fair access to education and healthcare, to think about accessibility and all the people that with this kind of pace that the technology is moving, we might be living behind because they are differently able, because they think differently, because they speak a different language. I think as academics, particularly, we are in unique positions because we don't have to, kind of really play this arms race and worry about the size of the language models that we can't build in our labs, but really thinking about how can we use this technology and improve it, and think about redesigning the principles that these companies are using to build these models to move towards a more just society. And then the next thing and the final thing, which I think about a lot, is thinking about how we can use this power again to address the major challenges, such as the problem of mental health, access to information. How can we communicate with different communities in Africa, South Asia, South Africa, America, critical information about pandemics, about global warming, and how should we be thinking about future of work, which is something that I'd be curious to ask about from the panelists here. How should we think about training people, or how can we predict this kind of change and movements in jobs in the next 5 years, 10 years, 20 years, and how can we use this technology to train workforces properly? Thank you for this opportunity, and I look forward to our discussion.
Thank you, Malika. Now, if people are invited to drop questions into the chat. There's already one question, into the Q&A, not the chat. Drop questions into the Q&A. There's a question that actually Colin has already given an extensive answer in the Q&A box. Let me just paraphrase it in case anyone else wants to respond. The paraphrase is that teachers from non-English speaking countries are encouraging students to use ChatGPT. At the same time, they hear recommendations to pause research and development in generative AI. So there seems to be kind of a conflict here. Is anybody care to comment on that?
I'm happy to quickly summarize what I said for the other panelists' benefits. So first was, I've been using it in my undergraduate class this semester and designed a final, which if they could figure out how to actually prompt GPT into giving a good answer, they would deserve one of the $300,000 a year prompt engineer jobs, right? So more power to them if they can do that. I think that is a skill that in fact we will want to be engendering, because just as lots of people don't really know how to do good searches on Google, a lot of people won't know how to do good prompts on these more powerful kinds of models. And then the second part was with respect to the letter that Musk and other people signed, that the pause is not well, the question was framed in terms of using generative models, but the pause is actually on developing more powerful ones. There's nothing in that letter says we shouldn't use the ones that we've got. Now, you might think there are arguments, including the ones we just heard, about sort of from an energy perspective and so on, not to use them. But I think that still the kinds of critical skills that we want our students to have with respect to these models, combined with the skills to actually use them productively, require us to use them.
Yes, thank you. It's it's interesting sort of to think about how we can learn to use and exploit ChatGPT and language models. I have a question also from John Rubin, who, since he's
wanted to add
sorry, go ahead.
Yeah.
Oh, sure. Thanks. Well, I'm just so speaking from a perspective as a writing program administrator, this is something that we've been thinking about in terms of education. Is, how much should they be used? And, I think there's another question too that I think is related here, that how quickly do you estimate the use of LLMs becoming an essential feature of our lives? I think we see them already being integrated into our word processing programs. I think there's a fairly good chance that they will be integrated into our word processing programs by fall. And so just considering, if we think about a kind of history of technology and how we've used different kinds of technologies to augment our writing in digital spaces for quite some time, spell check was resisted for quite some time, grammar check, these things are like very integrated into our lives. Now, we may argue that this is different. I mean, I would say that it is different. I think there's a lot of open questions about what is it that students have gotten out of writing that's not just the production of text, and that is like the processes of thinking, the processes of connection, logical formations, those kinds of things, which I think are really important for us to talk about. But in terms of will they be integrated into our writing processes and into our everyday lives, I think there's an absolute 100% chance of that moving forward.
And just to build on that, I totally agree with what Annette said and what Colin said. And I think there's also kind of this ethical issue or acknowledgement issue too. And if you are starting to use it, for example, in our research community now, there are all these policies about, you have to be very, ChatGPT is not allowed to be an author, and kind of figuring out the role and explicitly declaring it, which is a big, nobody ever thought about saying you used a spell checker is like an acknowledgement or as an author. But I think it does relate to the productive use of it and figuring out what you're using it for. And I've also heard kind of with integrating into the curriculum, if your assignments are such that ChatGPT could directly do it, perhaps, your assignments, it's a good way for you maybe to rethink your assignments and the skills that you really want the people to be getting out of them.
Any other comments on that question? All right. So John Rubin had a question. John, you want to just ask your question, or should I read it?
Well, I want to thank all the panelists, so I'll use this opportunity to say thank you very much for participating and for all of your interesting insights. My question is basically, what are the current areas of activity to try to sort of evolve the language models towards generating outputs that are actually logically consistent and factually correct, as opposed to the sort of hodgepodge we get now?
I can start quickly. I think what we're already seeing kind of making them, interoperate with other things which do focus on facts. So, I think with some of these, you can now click in it, like with Bard, and it will turn it into a search. And I've seen things with Wolfram. So that's kind of taking independent, like the existing version of the language model and existing version of something focused on knowledge and trying to cleverly figure out how to put them together. I think another direction is actually trying to do it directly within the language language model technology without, assuming there's this other component. But those are kind of at least two approaches that people are starting to look at.
Yeah, I would agree with that. And I hinted at the end of my 10 minutes that I had been in a bit of discussion with some other philosophers, in particular David Chalmers, who thinks that large language models sort of have the capacity to do it all. And I lean towards the second option that Diane mentioned, which is that our own neural systems have an architecture. It's not a uniform set of neural layers that all kind of just iterate the same basic process throughout. And so at some level, physiologically, they're all just neural cells, but they vary a lot in terms of their connectivity and the patterns of connections that they form. So I think that the kinds of things that will push beyond the limits of the current machine is going to require this kind of more careful attention to a cognitive architecture, not just a neural network that's bigger and bigger and bigger with more and more input to it.
Any other comments? All right. We have another question. How quickly do you estimate the use of LLMs becoming an essential feature of our lives? Any prognosticators? Not procrastinators, prognosticators.
I don't want to be the first one all the time, but Annette already told us that word processing programs are going to have it there. Whether it'll be essential, it'll probably be something you can turn on or off in the sense that you can also choose not to use the spell checker in your program if you want. But I think people will become more and more dependent on it.
Yeah.
And I think that I've talked to other people who are in the business world who go, I used to want some, let's say, advertising copy written for something that we're doing. I would hand it to an intern. Maybe later that day or the next day, I'd get 400 words and I'd have to edit it heavily. Now I can just give the same prompt to ChatGPT, and get something in a matter of seconds that I still have to clean up, but I've saved all of that effort with the intern. So I think that people who have the commercial imperative to get very basic writing tasks done quickly are going to find it essential for that reason.
Thank you.
And it's also, for people who aren't familiar, not just generating language, it can generate computer programs. And I think that's another use that people are increasingly not totally automating it, but, just like you said, viewing it as an intern of making a very close program.
And I would add to that, and images. So the latest ones, you can give it a verbal prompt to get an image. A former student of mine is in a startup doing exactly this, trying to make sure that the images that are generated are sanitized in various ways that respect privacy. So, for instance, they have written rules into the system that will, or prompts rather, that will make sure that any human in, let's say, an image of a restaurant scene will have the back of their head to the virtual camera, as it were, in order to not end up accidentally including something that resembles a real person in something that's going to go out for a massive kind of commercial audience. But yes, this is coming very fast in lots of areas.
I wonder if I can just add one more thing to that too, is to press on that term "our lives." So who is "our" in that? And I think that's, we're here, we're hanging out on a Wednesday night talking intellectually about AI. I think that's the way that we answered this question. But I think it's really important to consider the history of automation and who gets automated and who's kind of in the management perspective. So there is a kind of discourse around, say, OpenAI and a lot of the people designing these systems that wouldn't this be great? You have basically a stable of assistants to help you with things. And what that means then is the kind of people who might be doing that kind of assisting, or say, beat journalists, people coming out of college, the kind of on-ramp jobs to learning more sophisticated management and kind of upper echelon of knowledge worker, creative class jobs. That to me is kind of unknown, what that looks like, that kind of learning process. And what I said in the end of my presentation too, about whose language is being automated, how's it being represented, things like that. It's going to be part of a lot of people's lives, but how it shakes out is going to be really dependent on their orientation, their identities. There's a lot of different factors in that.
Yeah, thank you. I have another question. Someone writes, this is partly a question for Doctors V and Allen, but I'm interested in the other panelists' views. Are LLMs basically garbage in, garbage out systems? If it's all about the interface between the prompt and the training data, what's the difference from a garbage in, garbage out system? And how is a stochastic parrot different than that too?
You want to go first, Annette, since I keep...
Well, I'll just say really quickly that I think there's a lot of interesting language that comes out of these systems, but I started thinking about them as credit default swaps or collateralized debt obligations, CDOs, like that took the economy down in 2008. So it's like you take like all of this language that's like from lightly filtered web, Reddit links, like a whole bunch of stuff that's like literally there's some garbage in there, right? There's a lot of garbage in there, and then you repackage it and you make it look nice, and then like, oh look, all of a sudden it's like a high rated asset. And I think there's a little bit of that sleight of hand happening here. And whether we end up with some sort of crash like 2008 is another question. But I think it's important to ask that question about, what does it mean to have the garbage in, even if what comes out looks like pretty sanitized in the output.
Yeah, great. So the T in GPT stands for transformer, which is the particular kind of network architecture that's being used. So GPT has that architecture. GPT is actually a layer written around it, which has been subsequently trained. So GPT is trained. The P stands for pre-trained. The G stands for generative. And that has a whole bunch of garbage in it, as Annette just correctly pointed out. But then the second step of training that puts the wrapper around it uses human reinforcement learning, so human feedback for reinforcement learning. And in fact, OpenAI, I think, actually has outsourced most of that to people in Kenya, low-paying jobs, and their job is to feed some prompts to ChatGPT and then basically evaluate the response that comes back. And then that reinforcement, up or down vote on GPT's response is used to tweak the responses that ChatGPT will actually give. Now, so there's another place where you can get garbage in. That is, if the people who are tasked with this are not themselves really sufficiently trained to really push the system to its limits and find out where it goes wrong, then they're going to give it a lot of reinforcement and everything will seem hunky-dory until you put it online, where there's now a whole bunch of other people with a much more critical mindset exposing the problems that this thing has. And that, in fact, happened with ChatGPT. It's happened with Bing Chat. There's even a horrible case with one of these systems where somebody was in a conversation with it and they were suicidal, and it suggested that maybe they should commit suicide, and they did, right? So that kind of thing is not going on in the workshops where the reinforcement learning is being provided. It's only when you stick it out in the real world that you encounter these kinds of problems. And why didn't anybody think about that? This is sort of not thinking through the limits of how much we really know about how these things are going to perform in a wide range of circumstances that I was getting at with this notion of wisdom. So there's garbage in different places that leads to garbage out. And it takes a really critical mindset to figure out how to make it produce the garbage so we can figure out how to stop it. And there's an earlier transformer system that was explicitly built to supposedly give ethical advice that was released on the web about a year and a half ago, called Delphi. And it, in its first iteration, if you asked it, should I commit genocide to make other people happy? It would say yes. And they quickly realized they had a problem and did some fixes. And now it says, no, you shouldn't, and sort of flags this as offensive language. but it was just sort of ridiculous that they even put this out there in this state to begin with. So yeah, I think we have a real problem in the sense that the commercial imperatives to get this stuff out fast is kind of overrunning the caution that should be practiced with respect to making sure that the product is really ready for market in a way that's not going to harm people in all sorts of ways that we've only begun to see and imagine.
Yeah, go ahead.
I can also add that apart from this, Colin described this reinforced feedback loop that improved the output of ChatGPT. One thing that also played a very critical role was the particularly amazing data set that was written by experts and by another company in the Bay Area that just kind of produced the data, focused on producing the data. But typically, you know, with the GPT models, when we used to train these models or work with them, they're either trained on recipes or Wikipedia articles or social media data. So the text was shorter. Whereas when you look at ChatGPT, you see these longer kind of documents that are very well formed, that they have bullets, right? So this kind of organization of text and how sophisticated and professional it looks also is partly due to the quality of the data that they used for ChatGPT, which is very expensive. I think I don't know the exact price, but I've heard something around like $50 per document if you want to train so human experts have provided this data. Again, in terms of garbage in, garbage out, you know, I want to go back to Diane's point, you know, when she started her presentation, thinking that these models were here and we were using them in our labs and in our papers. So if you go to natural language processing conferences, GPT and similar models were around last year. Actually, half the conference in June of 2022 was talking about the prompting and how we can use these models. And so really kind of it's I think a mentality adjustment where we think about, yeah, it's a powerful model. It's a generative model, and we can use it to generate summarization. We can use it in educational tools. We can use it in tools that help doctors and nurses, right? But it's a tool that we are using it for particular purposes, and it's going to get better. Hopefully, it's going to be multimodal. It can do a better job reasoning and fact checking. But really like not thinking about them as beasts and thinking about them as better models that we already had in place. And again, going back to Annette's point, we are using them. They've integrated in a lot of the systems that we're using. So yeah, that's my take on it.
I have 2 more questions, and we have about 12 minutes left. We have to wrap up at 8:30. So hopefully we'll get these 2 questions in. This one, I think I'd like to hear Malihe first, since she had the looking ahead title. This questioner asks, so where does the panel think the world will be going with GPT-5? How disruptive do you think it will be to nearly every field and society as a whole once everyone catches on to what it can do?
So going back to what Colin said, I think this movement has started, and I think we should even think more about it as a whole, as a society, thinking about how we commercialize these models, how open, and this was a point that I think Eleanor was also asking in her question about the transparency, right? So sometimes when there are these races between different companies, you don't necessarily know the critical information that you need to know for regulating the outcome of these models. And that was also in my slides, really thinking about seriously, how can we regulate? When should we commercialialize? And on all of these are important issues that we should be thinking about, whether it's all from, whether we're technologists, we are actually in charge or involved in designing these models, but also if you're lawyers and policymakers. And in terms of GPT-5, I think GPT-4 already is impressive in several aspects. So if you think about certain critical applications, if we need language models that can generate text for us, this is going to be already impressive. But again, going back to my slides, we cannot walk around with these expensive large language models for anything that we want to design. So we will be thinking about ways that we can use these models in different ways to distill and build a smaller models that are more controllable and usable and safe for different applications that we're looking in the space of education and health and social justice and all applications that you can think about. So yes, it's scary because it doesn't seem like the policymakers or even some technologists are seriously thinking about the ethics and the impacts and ways that they're kind of making these products publicly available. But at the same time, again, going back to Annette's point, this power is kind of already here with GPT-4 and different versions of GPT. So yeah, it's here. And again, ending it with like the last point in my slides, we should all be thinking about, what we would like to do with these models, how we should, perhaps very soon, similar to what happened in Europe, they will ask us people to vote on how we are going to use this technology, or what are the dangers, or what risks they might impose on kind of on privacy and different issues. So kind of thinking about these, educating ourselves, and it is something that I want to end this note on.
Thank you.
Any
other comments on? Go ahead.
I was just going to add, like Malihe was just saying, I mean, it's here, and I feel like the disruption happened with ChatGPT. I mean, GPT-3 was out, and the interface was what really made it so disruptive, because it became so accessible outside, before our research community maybe was disrupted, but nobody else cared. And then ChatGPT came, and GPT-4 has now come out, and most people I don't think really have noticed, except maybe the research community again, but for people who are interacting with it. So I'm not sure, the next iterations, they'll be bigger and better, but at least I personally don't see the same kind of big disruption and qualitative leap that we saw when ChatGPT came out.
I'll just add that most people who are interacting with ChatGPT, if they haven't paid for it, are still getting the 3.5 version. You got to pay to get the 4 version. And so there's a motivation for these companies to try to convince us that 4 is so much better than 3.5 that you better pay for it if you're going to do all these wonderful things with it. And they have a point. It is better in a lot of respects, but I probed it a little bit, and it still fails in ways that the earlier version failed. Right. So depending what your application is, it may or may not be worth the money to pay for it.
All right. We'll try one more question. Colin already answered this question in part. This comes from a graduate student in the School of Education, currently exploring the impact of chatbots and AI on the future development of education. And this questioner wants to ask the panel how your teaching changes and what you feel about the effect of AI or ChatGPT on your classes.
I can say maybe I have really mixed feelings about it. So on the one hand, I've taught courses where we've played around with these kinds of things on automated writing. It's a lot of fun to probe the systems, figure out the edges of it, make it do cool things, try to figure out, new creative ways to write. So that's really, quite literally generative. On the other hand, I have, as I kind of mentioned before, some concerns about what this means for the learning of writing and the kinds of things that we've asked writing to do for educational development, cognitive development, considering other people's perspectives, lots of different things that we have writing do. And I think that, some colleagues here have talked about that you really need expertise to evaluate the output. I think Colin has mentioned this. And so, students can put something in and get something out. But if you have expertise in the area, then you can say, oh, well, that's obviously factually wrong, or, this is taking a particular take on something, but it's much more complex than that, or whatever. But if you don't have that kind of expertise to begin with, then getting that output can be a kind of answer, right? And I don't, I think many of us would agree. I know as a teacher, like my goal isn't as a writing teacher for people to find answers. It's to keep asking questions and to kind of probe different kinds of perspectives. And so this kind of, which I think maybe gets to a second question there about the subtle influences that interacting with these technologies may have on our thoughts, that there is a kind of, I prompt and then I get an answer in this kind of exchange-based way. And that makes me nervous as a teacher. So I'm not, I don't have a good way of working around that at this point, except to kind of work towards what some people are calling AI literacy, kind of showing how the models work and what's happening, what's not happening, that it's not some sort of magic. It's not actually a kind of intelligence. It's different from a human, and that there's a lot of really important things going on in the asking of questions and writing.
Thank you. I think we're out of time. I'd just like to thank John Rubin and Satish Iyengar for organizing the series, the panel for broadening our perspective, and the Zoom audience as a whole. Thanks so much.
Thank you.
Thank you, everyone.
Look for the recording online on the Science Revealed site. And for future Science Revealed events, of course. And yeah, thanks again, everyone. Thanks, Paul, for moderating. Thanks to all of you for the interesting questions. I guess we'll see how long it is before Pitt has a course on AI as one of its gen ed requirements. Speaking of the literacy that Annette mentioned, maybe not too far in the future. So yeah, take care, everyone.
Good night. Thank you.
Bye-bye.